All right, so today we're going to be talking about the absolute value. We looked at the absolute value a little bit when we were graphing and thought about how we graph something like the absolute value function. But now I want to talk a little bit more about this, the kind of the meaning of this, and how we solve equations that involve absolute value. So these are the absolute value of bars. We read this as the absolute value of x. And what does this mean? It means the distance this thing is from 0. Okay? Now if that's a little confusing, we have a variable in there. Think about it, so then it's not a variable, like -3. Okay? Now, you probably are familiar with the fact that the absolute value of -3 is just 3, but why? Why is that the case? Well, that's because what the absolute value really is doing is it's telling us how far whatever quantity is inside those absolute value bars is away from 0. So here's -3. Now, how far away is that from 0? Well, it's 1, 2, 3 units away from 0. So -3 is 3 units away from 0. Now, it's not telling us in which direction. That negative is telling us that we're left of 0, we're 3 left of 0. But absolute value doesn't care about that. It just wants a distance, a quantity, which isn't signed, meaning it doesn't have positive or negative value. That's why the absolute value of 3 and the absolute value of -3 are the same thing. Because both -3 and 3 are 3 units away from 0. They're just 3 units away from 0 in different directions. -3 is to the left of 0. 3 is to the right of 0, but again, absolute value doesn't care about that. It's just asking kind of distance from 0. Okay, so with that in mind, the question becomes, how do we solve absolute value equations? Well, what's an absolute value equation? First of all, well, it's an equation, meaning something with an equal sign, that has an absolute value in it, okay? So say we have something like this. The absolute value of x plus 3 equals 2. Well, what does this mean, okay? We can think of absolute value as giving distance from 0. That means absolute value is never negative, right? Because a distance is a positive number. So absolute value we can think of as getting rid of the negative, okay? So what does that mean in this case? Well, that means in order to solve this equation, x plus 3, the absolute value equals 2, two things can be true, right? We have two possibilities. Either what's inside the absolute value, x plus 3, is equal to 2, because then when I take the absolute value of that, I'll just get 2, because the absolute value of 2 is 2, or what's inside those absolute value bars could be equal to -2. If what's inside those absolute value bars is equal to -2, then when I take the absolute value, the negative goes away and I just get 2. Let's see what happens when we solve these two equations, right? We've gotten rid of the absolute value by writing two equations. And these are two equations that we can solve. Subtracting 3 here gives me x equals 2 minus 3 is -1. Subtracting 3 here gives me x equals -2 minus 3 is -5. So that means that we have two solutions, okay? -5 or -1. Notice that if we put either one of those into this equation, right? If I put -1 in for x, -1 plus 3, -1 plus 3 is 2, so I'll have the absolute value of 2, but that's just 2. Or if I put in -5, I'll have -5 plus 3. -5 plus 3 is -2, but the absolute value of -2 is 2. So by writing two equations, we can get rid of the absolute value and give us two separate equations to solve, each of which satisfy our original absolute value equation. Okay, so what this gives us is this gives us a process for solving absolute value equations. If we're going to solve an absolute value equation, the first thing we need to do is isolate the absolute value. In other words, we need to get the absolute value part by itself. So absolute value equals a number. And then we're going to write two equations. And by writing two equations, we can get rid of the absolute value, taking into account what the absolute value means. Either what's inside here is +2 or what's inside here is -2 for this particular example. And then we can solve the two equations, okay? Now, in general, that's going to work for us, but we are going to insert one additional step. I'm going to write up a couple of examples here, and we're going to go through them and kind of work through the process of solving absolute value equations. Okay, so here we have a series of simple absolute value, and we're going to solve them using that technique. We're going to check our answers. We're going to see something a little bit weird happens in one of them, okay? All right, so we've got the absolute value isolated. We'll work on that a little bit more later. The absolute value isolated means I've got absolute value equals a number. So I'm going to write two equations by thinking about what the absolute value means. The absolute value means the quantity inside here could be equal to 5, x plus 2 equals 5. Or the thing inside the absolute value, x plus 2, could be equal to -5, because when I take the absolute value, the negative will go away. So if we solve both of these, subtracting 2 from both sides here gives me x equals 3. There's one solution. Subtracting 2.
I am Groot.
Groot approves of solving absolute value equations. Subtracting 2 from both sides on this one we get x equals -5 minus 2 is -7. So here's our two solutions. And again, let's go ahead and check that these make sense. If I plug in 3, I'll get 3 plus 2, the absolute value of that. 3 plus 2 is 5, so I'll have the absolute value of 5, but the absolute value of 5 is 5. So we get what we're supposed to. Plugging in -7, I'll have -7 plus 2. -7 plus 2 is -5. So I'll have the absolute value of -5, which is 5. So both of these give good solutions, okay, or solutions that make our original equation true. Let's try this guy. Okay, x plus 2 equals 7. Again, we've got the absolute value isolated, so I'm going to write two equations, either x plus 2 equals 7 or x plus 2 equals -7. Solving both of these, subtracting 2 here gives me x equals 5. Subtracting 2 here gives me x equals -9. Let's go ahead and check these. Plugging in 5, I have 5 plus 2. 5 plus 2 is 7. The absolute value of 7 is 7, so we're good. Plugging in -9, I have -9 plus 2. -9 plus 2 is -7. The absolute value of -7 is 7, so we're good. Now let's look at that last one. Okay, our last one, x minus 3 equals -4. All right, so again, I can write two equations, either x minus 3 equals 4 or x minus 3 equals -4. That's what we've done before, right? Solving this by adding 3, I get x equals 7 or x equals -1. Now what happens when we plug this in? If I plug in 7, well, the absolute value of 7 minus 3. 7 minus 3 is 4, so I'll have the absolute value of 4, which is 4. Wait a minute, that's not equal. What happens if we plug in the other answer? -1 minus 3. -1 minus 3 is -4. Absolute value of -4 is 4. Wait, we're supposed to get -4. What's going on here? Well, what's going on here is we should have thought critically about our original equation. The absolute value of x minus 3 equals -4. Will that equation ever have solutions? I claim it won't ever have solutions. Why? Because I have an absolute value equals a negative number. That's silly. Why? Absolute value, remember, is always positive. The absolute value of something is always positive. So I have a positive equals a negative, -4. Can that happen? No, that can't happen. So this just has no solutions, okay? Now, in general, we don't even have to try solving it and then checking our answer to see there's no solutions. What we need to do is recognize in the beginning that if we have absolute value equal to a negative number, we're not going to have any solutions. It just doesn't make sense, okay? Now, one other thing I want to talk about here is please don't think of the absolute value bars as parentheses, okay? In other words, we can't distribute across the absolute value bars the way we would parentheses. It just doesn't work. Now, there are some times that you can kind of mess around with it if you think critically about what you're putting inside the absolute value bars and positives versus negatives. But in general, I would just say don't do it. Don't distribute across the absolute value bars the way you would parentheses, okay? Okay, so what have we done? We've kind of talked about the meaning of absolute value and how we solve absolute value equations. Last thing I'm going to do is just write up kind of a list about how we solve absolute value equations, and then in the next video, we'll practice that. Okay, so in general, to solve absolute value equations, we're going to isolate the absolute value term, check to see if a solution exists by making sure we don't have absolute value, something positive, equal to something negative. If a solution does exist, we're going to get rid of the absolute value by writing two equations implied by the absolute value, and then we're going to solve those two equations.